Well, hello everyone. This is again a short video tied to the ITS2300 class. This one recaps what is typically the first week of the class, very much an introduction and overview. And as usual in these videos, I'll do a quick review of the book chapter in terms of what to focus on, and then highlight just a couple of specific things to think through as you review the material. Right. So let's jump right into the book chapter, and I'm going to do this I'm going to use the table of content rather than the actual chapter for copyright reasons. So I apologize. I normally like to just scroll through the chapter, make it easy for you to recognize. But that would mean I would ultimately, by the end of the semester, put the entire book on video, which I'm not allowed to do. All right. So the book, of course, is the Fall Stevens book, TCP/IP Illustrated, Volume 1. That is linked from the class website, ITS2300.profcruise.net. All right. In this case, a couple of notes about the reading. The chapter is relatively long for an introductory chapter. One of the things to recognize is that nothing you read in that chapter, with some very few exceptions, stands on its own. It basically sort of describes all the things that the rest of the book will cover. So if you're reading something and sort of the concept makes sense but the details don't, I don't get too terribly worried about it, because we'll obviously look through it much more carefully in the remainder of the class. So that said, you definitely want to read the architectural principles, because the internet, even though we take it for granted now, was not the way the internet structure was not how we started networking. The telephone network that was really the first global network for voice communications only was designed very, very differently. So it's worthwhile reading through all the 1.1 sections and sort of understand what packets are, what connections are, what datagrams are, and those kinds of things. The end-to-end argument is something that you'll stumble across when you read about the internet. So you want to know what it is, and be able to sort of intelligently talk about what was really said about it. There's a lot of misconceptions about that. All right, we definitely want to read the section on layering, but that section then, after it sort of describes the general principles, gets into a lot of details. You can start kind of skimming when you get when you get to that area. We really want to just understand the concept, and I think you can sort of safely jump over the multiplex and demultiplexing chapter. We'll look at what we need to know in the TCP/IP suite, that section 122 is really probably more appropriate for like a computer science student who's studying operating system architecture. We definitely want to read about the TCP/IP suite, because those are the protocols we're actually working with in IT now. So you want to look at the ARPANET reference model, the multiplex and demultiplexing chapter. Again, same section. Again, same thing. Read the first part. There's an illustration there. Kind of understand what it's trying to tell you about the relationship between the protocols, but then when it gets into a lot of the details about specific protocols and how they're being used, we're going to get back to that. So skim over that and don't worry about it if that doesn't make a ton of sense right this minute. Port numbers you definitely want to read. Names, addresses, DNS you definitely want to read. You can pretty much safely skip 1.4. We'll get back to kind of larger sort of structural issues in network design. There's too much information there that isn't necessarily current for you to really have to spend time on that. The application design, I'm kind of torn. I think you ought to look over, figure out what the definition of a client server versus a peer-to-peer application are. And then we did talk about APIs, and so again, make sure from those three sections that you can define what a client-server application is, or what an API is, or what a peer-to-peer application is. But again, there's probably more detail there than you need. Definitely want to read about standardization, especially the request for comment section. And you can safely skip the remainder 1.7 on forward in the book, because they're again, this is just good information. If the time to read it, it's great. But in terms of minimally what you need to make progress in ITS2300, those aren't as important. Right. So let's highlight a couple of things that we talked about, starting with this whole concept of protocol layering, because it is really, really integral to how the internet works, and it is also important to understand before we try to understand the diagnostics we're using, right? So the problem that we had to solve was to build an application that has to do a lot of different things. Everything from physically connecting to a network medium, either a wire or a wireless connection, all the way to creating user interface so you can input information and read information coming back either visually or audio, watch a movie or whatever it may be. And trying to do all of that from scratch for every application would be incredibly inefficient. So we don't do it that way. We compartmentalize functionality and set it up so that this functionality can be reused. And so let me see if I can grab a. Yeah, there we go. So for example, I want a set of abilities that are typically called the physical layer. And I'll leave the layer off, you know what we're talking about. So the physical layer is a bunch of standards, a bunch of implementations that talk about how you talk over Ethernet or Wi-Fi. From a standards perspective, this is typically the IEEE that publishes standards around physical layer. So let's get another one of these guys. Make sure I have enough room here. Above that sits something called the data link layer. And so where the physical layer is kind of focused on hardware, and trying to transmission and transmitters, receivers, electrical properties, wireless encoding schemes, those kinds of things. The data link layer basically standardizes and implements the software aspects that control the transmission and reception of information in an operating system. And again, data link layer protocols typically come out of the IEEE. All right, moving up the stack, you can kind of see the convention is to have the stuff that is closest to the actual transmission at the bottom of the diagram, and then go up to the more abstract stuff. So now we get the network layer. And this is basically where the IP protocol lives. From the network layer on, the network layer is generally considered, generally standardized by the IETF in the RFC process that is in the book. The network layer primary focus is creating addressing and routing capability. So this is the subject of week 2 in the class. Then sitting above this is the transport layer. And in chapter 1, if you read about like error control and flow control, all that happens here. Now, what's interesting is there's really only one network layer protocol. Well, there are two, IPv4 and IPv6, but they're obviously very similar. There really is only one network layer protocol, one set of addressing, and 2 versions. So you might argue that 2 of them. There are many data link layer protocols. The most common ones, obviously, Ethernet for wired, and the various, the whole family of Wi-Fi standards for wireless. But there are also metropolitan area networks. Lots of Pico networks, but it's just all sorts of different things. At the transport layer, because we need a bunch of different functionality, there's actually a whole bunch of protocols. The two most common ones are TCP and UDP. So the TCP for sort of reliable file transfer, UDP for kind of ad hoc things that you kind of just throw it into the network and hope they get there. UDP would also, or some variant of UDP is used for streaming, where retransmitting information isn't always very useful. There are many other protocols, both in the transport layer. Some of them are utility protocols that are used internally in the network for diagnostics and configuration and operational purposes. So we'll get to all of that. But the idea is that we have these different layers and they encapsulate different functionality. And then the way the internet works, there really then is just one big layer that we typically call the application layer above this. And the old OSI model, the layered model that is in Chapter 1, basically breaks the application layer down into, I think, 3 different layers, which made a ton of sense, still makes a ton of sense. In many ways, that's still how applications are built, and using different building blocks. But for our purposes, we can just sort of think of it as this one big blob of capability that is modularized, maybe not necessarily in a strictly layered fashion, but there's still a lot of modules up there. All right, and so from our perspective, because we want to get into the labs, we want to get hands-on work, we're pretty much going to start at the network layer. So we're going to look at IP addresses, we're going to look at some routing, those kinds of things, and then we kind of from there move into the transport layer and sort of understand how TCP works in particular. And as we have time, we kind of jump in and do some data link layer stuff to make sure we understand how that works. So a couple other things to wrap this up. We did talk about names and addresses, right? So at the level of applications, I really want my users to work with names. So when you type something into the browser, you really want that to be a name, not a numerical address. But obviously, at the IP layer, I want addresses, which is a numerical identifier. All right, and so ultimately, and this is again something we'll look at later in the class, we have to find a way to translate names to addresses. All right, if the user gives me a name and I really need a numerical address, I need to translate. Each of the software layers has its own addressing scheme. So there are a couple other addresses other than IP that we have to worry about. TCP and UDP use the port number as an address local to the transport layer, right? So the IP address identifies an interface. It identifies essentially how to get to a computer. But the computer can have many different applications running, even multiple users may be using the computer. So the port number is used to disambiguate between those. So with the port number, a packet comes in, which program, which application to hand that data off to. So that is an address. It's a numerical address. Again, it's described in Chapter 1, and we'll use an example of it in the first lab. Then we have IP addresses, which are the topic of the second week. At the data link layer, because IP doesn't have to be the only protocol we use, at the data link layer we have something called media access control addresses. So there's a MAC address here, and that concept exists both for Ethernet, for wired networks, for Wi-Fi networks, for cellular networks. We'll kind of sneak that in between, as we get once we're sort of comfortable that we have all the info we need to advance in the labs. We'll kind of go back and take a look at that. And obviously, if the data link and physical layer use a MAC address, and the packet contains an IP address, I need obviously another translation. I need to be able to go from IP addresses to MAC addresses. We'll talk about how that is done as well. Okay. So that's kind of the basic info that the basic information that that we covered in week 1. Hopefully this is useful. As always, ping me on Teams or on my social media accounts if you have questions about this. And hope the review of the book chapter was helpful as well. So as always, thanks for watching the video, and we'll see you the next time.